dividing a line into certain equal parts or required equal parts. Let's say there is a line AB of some random length. For time being, let's consider 80 millimeter length, and we need to divide this line AB into 9 equal parts. We need to divide it into 9 equal parts. So if you take 80 divided by 9, you will get some value in decimals, and taking that dimension with a scale will not be feasible. So solution to that is a geometrical construction. So what we are supposed to do, draw one line through any of the end, let's say end A or end B. This angle, it has to be an acute angle. So that angle has to be less than 90 degree. You can take any random angle, it has to be acute angle. Then in a compass, take some random radius, and starting from this point, go on dividing this line. Take any random distance. So let's say this is first division, second, third, fourth, fifth, sixth, seventh, eighth, and ninth. So this is first, second, third, fourth, fifth, sixth, seventh, eighth, and 9 divisions. After this, take a roller scale or drafter and connect last division, that is 9th division, with the end B. So you will get this one line. Now you need to align your drafter scale or roller scale with this segment 9B, and from remaining divisions you just need to draw lines parallel to that 9B. All the lines that you are going to draw through remaining divisions, all those lines must be parallel to this 9B. All these lines has to be parallel to each other. Now once you do that, you will see your original line AB has got splitted into certain divisions, and those divisions are going to be your required divisions. So first, second, third, fourth, fifth, sixth, seventh, eighth, and 9 division. And if you measure length of every segment, the length of all those segments is going to be same. So your lines will be parted into 9 equal divisions. Next, drawing triangles. 30, 60, 90 degree triangle, or 55, 45, 90 degree triangle. You will be given length of one of the side of those triangles, and you need to construct that whole triangle. For example, you will be asked to draw a 30, 60, 90 triangle having maximum side length is equal to 70 mm. Now how you are going to do that? The first step, draw one of the segment. Length of this segment is going to be 70. Now from those two ends, you need to take 30 degree at one end and 60 degree at other end, or any two angles at any end. Let's say we are going to take around 30 degree at this end and around 60 degree at this end. So this angle is 30 degree, this angle is 60 degree. By default this angle is going to be 90 degree and you will get your required triangle. So same thing you can do with 45, 45, 90 also. Let's say this is the basic side. Again consider length of that segment is 70. So from here you need to draw one line which is inclined at 45 degree. So this angle has to be 45 degree. Similarly from this end draw other side which is inclined at 45 degree, and in that case this angle is going to be 90 degree. So you just need only length of one of the side of the triangle if you know the angle between all the sides. Next, polygons. Polygons or polygon is basically, let's say you started from this point A, you draw one segment, this is another, this is next connecting segment, this next connecting segment, and this connecting to the starting point. Now whenever this kind of closed structure is formed, this is called as a polygon. Similarly, or let's say if you measure the number, count the number of sides, this is 1, 2, 3, 4 and 5. So to be specific, this is a pentagon. Now if you consider this polygon, 1, 2, 3, 4 and 5, this is also a pentagon, but this pentagon is called as a irregular pentagon, whereas this one is called as a regular pentagon. So basically polygons are classified into regular polygons and irregular polygons. Regular polygons means when this is side 1, side 2, side 3, side 4, side 5, if you measure length of every single side, all these sides are going to be of same length. So when all sides of the polygon are identical or of same length, automatically the angle between any two adjacent sides is going to be same, and that polygon is called as a regular polygon. Whereas when polygon has got number of sides of different length, the angle between any two adjacent sides are different from each other, then that polygon is called as a irregular polygon. In case of regular polygon, the examples are equilateral triangle, square, this pentagon, hexagon or heptagon. So number of sides 4, 5, 6, 7, 8, 9, it could be anything. So these shapes are called as a regular polygons, which are going to be used in engineering graphics or engineering drawing. And let's talk about how to construct those shapes, or what are the various methods available to construct those polygons. First scenario, when side of the polygon is given and you have been asked to draw a required polygon. Let's say side of the polygon is 30 millimeter. We are going to talk about two methods. The first one is general method. In general method, Let's say this is a basic side, length of this side is 30 millimeter. Let's name this side AB. Now either from A or B, draw one line perpendicular to segment AB. Keep compass at center B, take radius equal to AB and draw this quarter circle. You will get this intersection point. Connect that intersection point with the end A. Next, bisect the original segment AB. So A center, radius is more than half of distance of AB. Draw one arc this side, on the other side, then interchange the center with B and draw two intersecting arcs and draw one line passing through those intersection points. Now the intersection of hypotenuse of the triangle with this perpendicular bisector, name it as center number 4, and intersection of this sector of circle with that bisector, name this as center number 6. This is point number 4. Point number 6. To locate point number 5, bisect this segment 4, 6. That is, take center 4, radius more than half of distance of 6, 4, arc on this side, arc on this side, then interchange the centers and two intersecting arc and connect those 2 points. So this point is going to be our point number 5. Now once you have got length of 4, 5 or 5, 6, that is value of single division, take that distance in a compass. You can locate point number 7, point number 8 and so on. You can locate any point. Similarly, you can locate point number 3 on this side also. Okay. Now when you want to draw a square, let's start with the square, that is 4-sided polygon. Take center 4, radius is equal to 4 to A and draw this circle. Okay, and once you have drawn that circle, take radius equal to original length AB. I'll make it thicker so that you can understand it in a better way. Take length equal to AB in a compass, start from B and go on dividing this circle. The circle will be splitted into 4 equal parts, and when you connect those parts together, you will get a square. Let's say now you want to locate a pentagon, that is 5-sided polygon. Choose center number 5. Pentagon is a 5-sided polygon, so choose center number 5. Radius again going to be 5 to A. Whichever center you have chosen, take radius equal to distance between that point and point A. Point A or point B, both are going to be equidistant points. So 5 to A radius and draw this circle. It would be slightly larger compared to center number 4. Again take radius equal to original side AB. Remember, this AB is going to be one of the side of the polygon and you are going to locate remaining sides. So take radius AB in a compass, either start from A or B. This time let's start with A and go on dividing the circle. You will get a, this time we have chosen center number 5, so we will get a pentagon. Similarly, if you want to locate 6-sided polygon, you have to choose center number 6, radius is equal to 6 to A, draw this circle, then take original radius AB in a compass and go on dividing this circle. you will get a hexagon. Sorry. You will get a hexagon. Okay. So in the same construction, you can construct any required polygon, and because of that one, this method is called as a general method. Now the another method, again when side of the polygon is given and you have been asked to draw polygons. Okay, next another method based on side of the polygon is given. In this case, let's say this is side AB. Length of this side is 30 millimeter, and I am going to construct the, for time being, let's say we are going to draw a pentagon, that is 5-sided polygon. Now as I am going to draw a 5-sided polygon, the total included angle in case of circle is 360. So I will divide it by 5 because I am drawing a pentagon. So this value you will get 72 degrees. This 72 degrees is called as external angle. Now what is external angle? From this point A, I'll draw one line which is inclined at an angle of 72 degree, and this angle is called as a external angle. This angle is called as internal angle. So from this sketch you can easily get that internal angle can be 180 minus external angle. So that will become, in case of pentagon, 108 degrees. For different polygons, those two angles are going to have different values. We are drawing pentagon, so for pentagon, external angle will be 72 degrees and internal angle will be 108 degrees. So this angle is going to be 108. So similar to this one, from this end draw one line. This angle is going to be 72, this angle is going to be 108. 30 mm is the length of the side. So this segment mark 30, this segment mark 30. Take 30 radius in a compass, keep compass over here, draw one arc from this center, draw intersecting arc from this center, and complete the pentagon. Now you can see this angle will become external angle 72, this will become 108. This angle, external angle, will become 72, this internal will become 108. If you consider this line, this angle is going to be 72 and this angle will become 108. So by referring this sketch, you can construct any required polygon. You just need to divide 360 by that specific polygon number of sides, and that way you will get external angle, and 180 minus external angle you will get internal angle. Now we'll see one method when you will be provided with either a radius or diameter of the circle, and you will have to draw polygon inside the circle, or you will have to draw polygon outside the circle. First scenario, you will be asked to draw polygon inside the circle, and second scenario, you will be asked to draw polygon outside the circle. So first Let's consider you have been provided with radius of circle is equal to 60 millimeter, just for example purpose. So let's say this is a circle that you have drawn. Now next step, draw horizontal diameter. Let's say in this circle you have been asked to draw a pentagon. Depending upon polygon to be drawn, we need to divide this diameter into equal parts. I'm going to draw a pentagon, so I'll have to divide this diameter into 5 equal parts. For that one, you can use the geometrical construction we saw earlier. You will have to split this diameter into 5 equal parts. So 0, 1, 2, 3, 4 and 5. So these are the 5 divisions. Next, keep compass on one of the end of the diameter and take radius equal to diameter and draw this arc. Interchange the center with this other end, same radius that is equivalent to diameter, and draw another arc. You will get one intersection point. This nomenclature, this always supposed to start with 0 and last or other end of diameter must be the number indicating number of sides of the polygon. Okay, so 0, 5. The second division, connect it with this intersection point and extend this line further till it have intersection with the circle on the other side. So here you will get this segment. This segment is nothing but side of the polygon that you are going to draw. In our case, we are going to draw a pentagon, so this is now side of the polygon. So take that much distance in a compass and go on dividing this circle. You will get a required polygon. Sometimes they may ask side of the polygon that you can measure and specify. So this is the method. This is one of the method. There are few more. We are going to discuss this one method only. So by this method you can construct polygon inside a given circle. In this specific case, we have drawn a pentagon inside a circle of radius 60 millimeter. Next, when you have to draw pentagon outside a given circle, again we are going to draw a pentagon, but this time outside the circle. So for this one, we need to split this circle into 5 equal parts. We are drawing a pentagon, so there has to be 5 equal parts. So let's say this is first division, this is second division, this is third division, this is fourth division, and this is fifth division. To get those divisions, what you can do, we know included angle for circle is 360, so divide by 5, you will get value of single division. So this is going to be 72, 72, 72, 72 and 72. Now next, we need to draw tangent to all these points to the circle. While drawing those circle, what we need to take care of, the tangent that you are going to draw must be perpendicular to this division line. So this would be another tangent, this would be another tangent, this would be another tangent, and this would be another tangent. Now when you draw those tangents and connect intersection points of those tangents, you will get a required polygon. Last, that we are going to talk about. Drawing circle inside a given polygon.
It's 14 hours.
Any polygon, it could be a square, it could be a pentagon, anything. The procedure is going to same. What you need to do, what you are supposed to do is consider any two adjacent angles and draw bisector of those two angles. Once you draw bisector of those two angles, those bisectors will intersect each other at some point. From that intersection point, draw a perpendicular to one of the side of the polygon, and this perpendicular is going to be the radius of our circle. So the two requirements to draw a circle, first requirement is center and second requirement is radius. So those two requirements we have satisfied. So take this center, this radius in a compass, and draw a circle. That circle will touch all the sides of the polygon. So this is for triangle. Same thing you can do for the square also. Draw a perpendicular bisector, draw angle bisector, intersection point, draw a perpendicular to one of the side, and this is radius, this is center, and draw the circle. Okay, so when you draw it with a scale, you will get a perfect circle. So this way you can construct or draw a circle inside any polygon. One thing I failed to specify over here, this method where you are going to draw a pentagon inside a circle, this one is called as inscribing a polygon inside a given circle. The question might be like, inscribe a polygon in a given circle, and this one is called as circumscribing polygon or describing a polygon about a given circle. So when you are drawing polygon outside a circle, the wording might be circumscribe the polygon about a circle or describe a polygon about a circle. Now the last thing, to make it more complicated, the question might be like, draw a square of some specific dimension and draw 4 equal circles inside that square in such a way that one of the circle touching two adjacent circles, touching, not intersecting, touching two adjacent circles and touching one or two sides of the square. Touching one or two sides of the square. So we are going to consider here it is touching two sides of the square, and here it is touching one of the side of the square. So when circle is to be in a contact with two adjacent sides of the circle, simply draw or divide the square into 4 equal squares. Draw angle bisector for this square, draw angle bisector for this square, draw perpendicular, so that is going to be radius. So this is center and this much is radius, and draw a square. Okay, so same procedure can be repeated for all other squares, and 4 squares can be drawn. Now here you can see the circle is going to be touching two adjacent circles, and it is touching two sides of the square. Next, when circle is to be in contact with two adjacent circles but touching only one of the side of the square, in that case draw or connect those two opposite corners with each other. You will get 4 triangles instead of square, and in this triangle draw angle bisectors, intersection point, draw perpendicular, that is going to be radius, and then draw a circle. So this is one circle. When you repeat procedure for other circles, you will get 4 equal circles, and those circles are going to be in contact with 2 adjacent circles and touching only one of the side of the square.